Hi guys, this is Mrs. Denton. Today we are going to review our product rule of exponents with some different types of problems than you've seen before. Grab you some notebook paper, make sure you have your calculator if you need it, and get ready to write some notes. So we're going to first of all talk about multiplying monomials. Monomials are either a number, variable or variables, or a combination of both, multiplied together as a single term. You multiply monomials using the product rule. Here's an example of the product rule. So if I have x raised to the a times x raised to the b, I can simply take those two exponents, because my base is the same, and add them together. So that would now look like x to the power of a plus b. The product rule states when multiplying powers with the same base, you add your exponents. Here's some more examples. In this example here on the left, I have the same base of g. So I'm going to take the exponent of 4 and 7. I'm going to add or combine those and get g raised to the 11th power. I can also do this same product rule with a negative exponent. My base is the same, so I'm going to take negative 3, combine it with 5, and get the n to the second power, or n squared. The last example, we have w to the 4th, a squared times a to the 7th. Now we're looking at this entire term being multiplied by this term. Now w to the 4th has nothing else to combine with, so it simply moves to my answer. My a's, however, share the base of a, so I'm going to take that 2 and 7, and I'm going to combine those, and that's going to allow me to have a to the 9th power. Product rule with coefficients. If you'll remember, the coefficient is the number, or if there's not a number, it's understood to be 1 out in front of the variables that may have exponents. When using the product rule with monomials that have coefficients, you multiply the coefficients. Now, look at the examples here. When we say coefficient, we're talking about those number values. So here's my monomials, 2n to the 4th times 5n to the 5th. So I'm going to simply take that 2 and that 5, multiply them, and get 10. Then I'm going to take my exponents that have the same base, and I'm going to add those, and that's going to give me n to the 9th. Okay, same thing over here on the second example. We have 4c to the 4th, d to the negative 3rd, times 7c to the 3rd, d to the 5th. So I'm going to take this coefficient 4 and this coefficient 7, and I'm going to go ahead and multiply those two, and that's going to give me 28. And then I'm going to simply just take each of these variables separately, my base of c that's the same, and take those two exponents and add them together, because this is the product rule, so we add, and that's going to give me c to the 7th. My next variable is d, and I'm going to take a negative 3 and add 5, and that's going to give me d squared. If there is not an exponent, make the exponent equal 1. So basically just replace that exponent with a 1. For example, 3b times 6b, I can put a 1 in there. I'm going to multiply my coefficients, 3 times 6, and that's going to give me 18. And then I'm going to take those variables and add those exponents. And that would give me b squared. Remember, anything to the power of 0 equals 1. So we're going to see some of that within this lesson as well. Here's this example, 2x squared times 2x to the negative 2 power. Okay, I'm going to take those coefficients, 2 times 2, and that's going to give me 4. And then I'm going to take those variables and I'm going to add their exponents. And if you notice, these exponents are negative, so they're going to give me 0. So x to the 0 power is the same thing as 1. So basically 4 times 1 is the same thing as just simply 4. So you may not even see the variable in the final answer. Okay, answers with negative exponents. If an exponent in your answer is negative, you must move that term to the bottom and turn your answer into a fraction. Now, with that being said, if you have an exponent in the bottom of your fraction already, then you're just simply going to move that to the top of the fraction to turn it into a positive. So any location that our negative exponent is located, denominator, numerator, remember crossing it across the fraction bar or moving it across the fraction bar turns it into a positive. And your answer should only contain positive exponents. Never give a final answer with a negative exponent. Here's an example. Let's look at, we have a coefficient of 5 and a coefficient of 7. So we would go ahead and multiply those coefficients and get our 35. And then we're going to look at the variable n. Now we're working with multiplication, so we're going to take -4 and add -2. And that's going to give us n to the -6 power. Now my 35 is okay, but this cannot be a negative. So it's not a fraction, but we can turn it into a fraction, and we can move this to the bottom, and that will allow it to become a positive. Remember when we first started looking at negative exponents and we put those into our calculator and our calculator automatically turned it into a fraction because we were using the reciprocal to get that into a positive exponent. So even though we do not start out with a fraction, we may end up with a fraction if we have a negative exponent. Here's another example. So we have x to the -5th times 3x to the 4th. Now there's not a coefficient out here in front, but I could think about it like a 1 if I needed to. And 1 times 3 is simply 3. Then I'm going to take those exponents with my base of x, and I'm going to add -5 plus 4. And that's going to give me a -1. Can't have a -1 in my final answer, so that needs to move to the bottom of the fraction and become a positive. Now, that would leave me with this. You're not going to see x to the first power. You're going to see just x simply by itself. And in this situation, we have a 3 over x. Okay, adding and subtracting monomials. So you can simplify an expression by adding or subtracting monomials if all of the variables in each of their exponents are exactly the same. So basically we're talking about like terms. And it's been a while since we've actually just worked specifically with like terms. So let's talk about one strategy that you can use that we've talked about before. Taking your problem or your expression that has more than one term and separating it so you can see exactly how many terms it has. So this problem has 4 individual terms, And you can see in the first one we have a 3AC, the second one has a 4BC, the third one has a 5BC, and the last one has a negative 7AC. The sign in front of the coefficient always goes with that term. So if I want to pair up like terms, they have to have all of the variables and each of their exponents exactly the same. Now there's no exponents in this first example, but there are variables. So this first term has a 3AC. This last term has also the AC, but it's a negative 7. So I'm going to think about these coefficients, and I'm going to take 3, subtract 7, put it in my calculator, and I'm going to get a negative 4. And I'm going to move that over here with that AC, so I have one term complete. Now I've combined those and simplified it. Now I'm going to take my next term, 4BC, and it looks like the second and third term share the BC. Both of them are positive, so I can just simply put 4 plus 5, and that's going to give me a 9, which is a positive BC. So that's how you add and subtract monomials. You take the sign in front of the term. Okay, let's look at another example. And let's break this one up as well too. So over here on the left, whoops, we've got one term there, two terms. Let me erase that real quick, start over, and take a little bit of that old problem out so we can see clearly here. So now we can see our first term, our second term, our third and fourth term. So with our first term we have a t squared and a u to the third. I don't see any other terms that have t squared or u to the third, so this one's not like any of the others, so it just moves straight over to my answer. There's nothing I can combine there. The second one has a tu with a negative out in front. There's not a number, but if I needed to, I could replace it with a 1. That lets me look at it like a negative 1. The third term also has a tu, and it has a positive 3. So I'm going to put these two together, and I'm going to put negative 1 plus 3 in my calculator, and that's going to give me 2. And then I'm just going to put the tu with the 2. And it's a positive, so that's why I have a plus sign. So I finished those. And the third one, well, the third one's all by itself because there's nothing that just has t squared. So it's just going to move over to the answer, and it had a negative out in front of it, so it's a negative in my answer. So you could possibly have some terms or parts of the monomial that do not combine, so therefore they move straight to your answer. And the last one, let me take that out. And let's take these 4 terms and separate them so we can look at them individually. Now I'm going to just start with the first one, 4x squared. Is there anything else with an x squared that I can combine it with? Yes, right here. So take that coefficient, 4 subtract 2, and that's going to equal 2, and move that over to my answer, and then the x squared stays there, moves over here. Okay, the second term has negative 6 ux to the third. Our last one also has a ux to the third, so those two can be put together. So we're going to take the negative 6 and subtract 3. Put that into your calculator. That's going to give us a negative 9. So that's our sign and our coefficient. and then the ux to the third simply moves over here with it. So your final answer actually has two terms. And we don't know the value of these variables, so that's as far as we can go with each of these.